Students, I hope you are reading the topics which we discuss in class, as I used to advise you to read those topics from different resources to get wider information about those topics. Keep reading all these topics from different resources because you should not limit your knowledge for any topic. Okay, so as I hope that by now you are clear with all the parameters and hyperparameters associated with machine learning model, including neural network, right? And at last we discussed dropout in neural network. So this is just to remind you that this was the last slide, I think, which was discussed. Okay. And I think we also discussed that how dropout is applied to neurons of hidden layer. So for example, and we discuss the same example. If there are, here you can see that in left side figure, like 6 neurons are there, and the first two neurons, they are 0. So we have set weight value for the first two neurons to 0. In next iteration, as you can see in right figure, the middle two neurons, for middle two neurons, the weight value is set to 0. So in either case, the dropout rate is 2 divided by 6 because we have set weight value to 0 for 2 neurons. So 2 and total 6 neurons are there in this layer. So 2 divided by 6 is 1 by 3. So we can try with different dropouts. We can record the results and then we can check that which combination is giving, like for all, in fact, for all hyperparameters, you can set range and you can create different combinations and you can try with different combinations and record the results. And finally, you can analyze that which combination is giving you good result. Okay, fine. So now follow. It was also discussed in last class. Okay, now let's discuss the activation functions. So let me first tell you that what exactly the activation function is. It is also called, as mentioned here, it is also called transformation function, right? Transfer function, sorry. It is also called transfer function. These activation functions are actually mathematical equations that determine the output of a neural network. As you can see in right side figure, basically what we do that we weighted sum of inputs is passed through the activation function, as you can see in this figure, right? So this activation functions basically decide to deactivate neurons or activate them. They decide whether to activate the neuron or whether to deactivate the neuron. So they decide activation, deactivation of neuron to get the desired output. And that's why its name is activation function, because it decides whether to activate the neuron or deactivate. And that's why the name of this function is activation function, which is basically mathematical equation. In neural network, as a weighted sum of input is passed through the activation function. And as you can see here, like you can define it like this. Sorry, I am on. Okay. As you can see here, y is equal to activation function. And here in this activation function, we pass the weighted sum. So as you can see in this figure, like see here is the activation function and weighted sum is passed to that function. And like this is to determine whether to activate or deactivate this neuron, and then you get output. Okay, then finally you get output. Okay, so this is the basic idea about the activation function. Before we move further, let me tell you why we use activation functions in neural networks, why we use this activation functions. This activation functions, they convert linear input signals, linear input data to non-linear input signals. Earlier, we discussed what is linear and what is non-linear. And if you remember, with one diagram we discussed, if you can separate input samples, for example, in two classes, not always two classes, but let's say, for example, in two classes, and if those two classes are separable by a line, then we can say that the input data is linear data. So activation functions, they convert this linear input signals to non-linear output signals. And in addition to this activation functions, they can be differentiated. And because of that, back propagation can easily be implemented. So that's why also we need activation functions, because this activation functions can be differentiated, and as they can be differentiated, we can use back propagation in neural network. So after this topic, like after a discussion of activation functions and loss functions, we are going to discuss feed forward and back propagation network. So that time you'll come to know that how these activation functions are useful for back propagation in neural network. This activation function is used to determine the output of neural network, like yes or no. As I told you, it determines whether to activate the neuron or not. So activate or not. So it is like output should be yes or no. So it maps the resulting values between 0 to 1 or -1 to 1, etc. Like different range are there. I'll show you. And this range depends on the type of activation function you use. And this activation function, it creates range for the values. All the activation functions which are available, they are divided basically in two categories: linear activation functions and non-linear activation function. So let us start with activation function. This, as you can see, the function is a line or linear, as shown in the graph on right hand side. This function, this activation function, is line or linear. The output of the function will not be confirmed between any range, right? So linear, this simple straight line function is directly proportional to the input. That is the weighted sum of the neurons. And so it has this equation, f of x is equal to x. You can see that the x-axis represent x and y-axis represent f of x. So the function is like f of x is equal to x, or you can say f of x is equal to kx, where k is a constant. So linear function is very simple function. Its range is -infinity to infinity. -infinity to infinity. The line can be from any point in on negative side to any point on positive side. So -infinity to infinity, because ultimately we are drawing a line. And this function does not help, like though it is very simple and it is very simple to implement and very simple to understand, it does not help with the complexity or various parameters of input data which we feed to neural networks. So if the data is complex, this linear activation function is not useful. Unlike binary step function, if you remember, we discussed binary step function earlier. So unlike binary step function, this linear activation function can handle more than one class, but it has its own drawbacks too. This linear activation function, it is usually used for binary classification, but it can also be used to handle more than one class, that is binary classification. Okay, and it has drawbacks like the problem with linear activation function is that it cannot be defined in a particular range. It cannot, because what is the range with linear activation function, as we just discussed, -infinity to +infinity. So it cannot be defined in a particular range, while other activation functions, which we will discuss, they have a particular range, but this doesn't has a particular range. Okay. Moreover, as it is a line, you can see that we can have one class on one side of the line, other class on the second side of the line. So like binary step function, usually it is used for binary classification problems. And no matter how many layers the neural network has, how many layers means hidden layers, how many hidden layers the neural network has, the final layer always works as a linear function of the first layer. So this makes neural network unable to deal with complex problems. Another problem with this linear activation function is that the gradient is a constant and it does not depend on the input at all. Because of this, during back propagation, the rate of change of error is constant. When we use this linear activation function, the rate of change of error in back propagation is constant. And when it is constant, it leads like poor improvement in neural network. Neural network will not really improve with constant gradient. Gradient should not be constant. So that is the problem. That gradient with this activation function is constant and it does not depend on the input. So these are the drawbacks of this linear activation function. Okay. Now, if we move further, we have several nonlinear activation functions. Here, before we discuss nonlinear activation functions, I would like to discuss terminology related to this nonlinear activation functions. Mainly, these two terms are related to nonlinear activation functions: derivative or differential, and monotonic function. Fine. So, what are these terms? Actually, the nonlinear activation functions are most used activation functions today, and nonlinearity helps to make the graph look something like shown in right side figure. So it is nonlinear, right? Because there is no line, it may be curve. And it makes it easy for the model to generalize or adapt with variety of data and to differentiate between the output. So this terms derivative or differential, it is change in y-axis with respect to change in x-axis. And this is also known as slope. As you all have studied in mathematics, this is known as slope, change in y-axis with respect to change in x-axis. And what is monotonic function? So we can say that, activation function is derivative or differential if there is a change in y-axis with respect to change in x-axis. And monotonic function means a function which is either entirely non-increasing or non-decreasing. Non-increasing or entirely non-decreasing. So that is called monotonic. As we also use word monotonous, same, right? So this is monotonic function. Continuously, it either increase or decrease. So that is called monotonic function. Thus, nonlinear activation functions, they are mainly divided on the basis of their range or curve. They are mainly divided on the basis of their range, or you can say curve. Okay, so let us now start discussing different nonlinear activation functions. This also, like those who have studied machine learning, they might be familiar with this activation functions too. But uh, you can surely like consider as the reason logistic activation function. The sigmoid function curve looks like a S shape. Suppose I want to predict from CT scan of I want to I want to predict what is the probability of, remember the definition of difference. You can consider any 2 points on this line and you will find slope, right? And that is like noticeable. The slope is noticeable. So like it is differentiable and the function is monotonic, but function's derivative is not. Function is monotonic, but function's derivative is not monotonic. This logistic sigmoid function can, though it is very good for many real life problems, the disadvantage is that this logistic sigmoid function can cause a neural network to get stuck at the training time. And the softmax function is more generalized logistic activation function, which is used for multi-class classification, which I don't remember it is there in this slides or not, because the slides are there. Okay, fine. So this is about the very simple non-linear sigmoid activation function. Okay, now let's discuss the next non-linear activation function, tanh or hyperbolic tangent activation function. tanh is also like logistic sigmoid, but better than logistic sigmoid. It is better than. Why it is considered better than? Here you can see that it is also S-shaped curve. tanh is also S-shaped function, sigmoidal function. The range of tanh function is from -1 to 1, and that's why we consider it better than sigmoid function. Sigmoid, what is the range of sigmoid? Just we discuss 0 to 1. 0 to 1. And what is the range of this? As you can see in the figure right on the right side, -1 to 1. Right? So instead of 0 to 1, it supports -1 to 1. The advantage is that the negative inputs will be mapped strongly negative and the zero inputs will be mapped near zero in the tanh graph. Please listen it carefully because this is how different activation functions differ from each other. The advantage of tanh activation function is that negative inputs will be mapped strongly negative and the zero inputs will be mapped near zero in the tanh graph. That is the advantage of this. And the function is differentiable and the function is monotonic also, while its derivative is not monotonic. While in previous case, derivative is monotonic. While here, function is monotonic, while its derivative is not monotonic. And this tanh function is mainly used for classification problems, classification between two classes. It is used for classification between two classes, that is binary classification problems. Both this tanh and previously discussed logistic sigmoid activation functions, they are used in feed-forward neural networks, which is part of this first module of your syllabus, feed-forward neural networks. So both this tanh and logistic sigmoid activation functions are used in feed-forward neural networks. Okay. Now the next activation, the next nonlinear activation function is ReLU. Okay, now what is ReLU? ReLU stands for rectified linear unit. Rectified linear unit. ReLU is the most used activation function in the world today because it is used in almost all the convolutional neural networks or deep learning. So this is your subject is deep learning for computer vision. And for computer vision, mainly convolutional neural networks are used. And for this convolutional neural networks, this ReLU is very popular, right? So probably like if you are, I don't know whether you are doing practicals for this subject or not, but if you implement the concepts of this subject, then you will require to implement this ReLU when you use convolutional neural network. So this is the most popular. Why this is the most popular activation function today? Because it is used in CNN, and today in almost like all the object detection and image classification problems, we use this CNN. So ReLU is widely used today. As you can see in figure below, ReLU is half rectified from bottom. ReLU is half rectified. You can see the left part of the ReLU graph. Left part of the ReLU graph. So it is half rectified from bottom. So f of z is 0 when z is less than 0. Please listen carefully. F of z or f of x. Okay, f of z or f of x. आप x एक्सिस पे x ले रहे हो तो f of x. X एक्सिस पे z ले रहे हो तो f of z. So f of z is 0 when z is less than 0. Right? So for negative input values, it is 0. And f of z is equal to z when z is above or equal to 0. That is for positive values, it is 0 or above, like it is equal to z when z is above or equal to 0. Right? So range for it is but obvious. You can see in the right side graph that what is the range for this ReLU activation function. The range is from 0 to infinity. From 0 to positive infinity. Like it's very clear from this graph that it is from 0 to positive infinity. Right. While in case of sigmoid, you can see that like ReLU versus logistic sigmoid. So see the left side graph, right? It is curved. We have like, we can have negative values are mapped to negative and positive are mapped to positive. So we have like a left side, which represents the negative part. You can see that right side presents the positive part, and we have S-shaped curve. Okay. Fine. So range is 0 to infinity, and the function and its derivative both are monotonic. But the issue is that all the negative values, like that issue, like anyone can tell the issue with this ReLU activation function. What is the issue? All negative values, they become 0 immediately, which decreases the ability of the model to fit or train from the data properly, because all the negative values, they become 0. So model is not learning from negative values, right? So train from the this decreases the ability of model to train from the data properly. That means any negative input given to ReLU activation function turns to value into 0 immediately, which in turns affect the resulting graph by not mapping the negative values appropriately. So this is the only problem with this ReLU activation function. Okay. Now, if we move further, leaky ReLU. Okay. This leaky ReLU is an attempt to solve the dying ReLU problem. You can see that left side figure shows the ReLU and right side graph shows the leaky ReLU. And you can also see the difference in these two graphs. Instead of 0, you can see that. So I can see that you can see the leak, right? You can see the leak. The leak helps to increase the range of the ReLU function. Just it helps to increase the range of the ReLU function. Usually the value of A is 0.01 or so in the function f of y is equal to ay. In right graph, on the right side graph, you can see that the bottom half represents f of y is equal to a into y. A is not, when A is not 0.01, then it is called randomized ReLU. So like one more ReLU, we are introducing randomized ReLU. We have ReLU, we have leaky ReLU, we have randomized ReLU. So when A is usually, the value of A is usually 0.01 or so. But when A is not 0.01, then it is called randomized ReLU. And so the range of leaky ReLU, like, okay, now can you tell me the range of leaky ReLU? Can you write in chat box? We know the range of ReLU. Range of ReLU just we discussed. What is the range of ReLU? That also you can write. ReLU range and leaky ReLU range from these graphs. So I'll come to know whether you are with me or not. Okay, 0 to infinity for what? You specify the name of function, ReLU or leaky ReLU. Leaky minus infinity to infinity. 0 to infinity ReLU. Okay. Yeah, everyone, write your answer. This is to check whether you are with me or not. Yeah, good to see many answers. Okay, so fine, your answer is right. For leaky ReLU, the range is minus infinity to plus infinity. And for ReLU, the range is 0 to infinity. That we discuss when we discuss ReLU. And even in this graph on left side, you can see that the range for ReLU is 0 to plus infinity. And the range for leaky ReLU is minus infinity to plus infinity, positive infinity, right? Yeah, fine. Okay. And both this leaky and randomized ReLU. Leaky ReLU is when A is 0.01 or so, and randomized ReLU when it is not 0.01. So both this leaky and randomized ReLU functions are monotonic in nature, and their derivatives are also monotonic in nature. Okay, fine. So this is about the commonly used linear and non-linear activation functions. Now, before we move forward, before we move further, let me tell you why derivative and differentiation is used with this activation functions. When we update the curve to know in which direction and how much to change or update the curve depending on the slope, we use this derivative or differentiation. That is why we use differentiation in almost every part of the machine learning and deep learning. That is the reason here too, right? So it tells us that in which direction and how much to change or update the curve. So for that, we use this differentiation. Okay. Now, if we move further, here all this activation functions are plotted, and you can see the change and you can see the range difference in all these activation functions. You can also notice difference here in cheat sheet, which I have included. You will find such cheat sheets online, right? You will find such cheat sheets online. You can see that I have taken it from internet only. These are the different activation functions. Like, see, the second is binary step, which we discussed earlier. The first is linear binary step. Third is sigmoid. Fourth is 10H. Fifth is ReLU. Okay, then one more soft plus leaky ReLU and exponential linear unit. So these are the different activation functions. You can see their plots. From plots, you can also decide their range, which is given in the last column, right? That what is the range for each of them. For most of the activation functions, the range is between 0 to 1 or minus 1 to 1. And but for some of them, it is also up to infinity. Okay, derivative is also given, and equation, the third column represents the activation function. That this, what is this equation, right? So activation function equation is also given, equation for each of this activation function, and their derivative is also given. Fine. So such cheat sheets, like many cheat sheets are available with, see this, another cheat sheet, plot and derivative and equation. So such several cheat sheets are available. Okay. So this helps you, like such for every topic nowadays in many of the subjects, whether it is Python programming or Python for data science or machine learning. For many topics, you will find such cheat sheets, and such cheat sheets are very useful during the exam time. You can refer such cheat sheet, which will brief you about every uh, topic or every function in very short time. Yeah. Ehsas. Okay. Yeah, Ehsas, you can ask your question. Ehsas, can you hear me? Or you can write your question in chat box. Okay, okay, it is already there. The first cheat sheet shows the leaky ReLU range to be -1 to 1. Okay, let me check. Oh, sorry. Leaky ReLU, where is leaky ReLU? Okay, -1 to 1. And here is there difference? Where is leaky ReLU? Oh, leaky ReLU is not here. Okay, but no, as we discussed, it is minus infinity to infinity. And the reason is like it's very clear from this, right? But the range of a randomized ReLU, it may be like slightly different, but you can see it is minus infinity to infinity. It depends on the value. Leaky ReLU is on right side. It depends on the value of A, that what value you choose for A, and accordingly the range may vary slightly. Fine. Okay. Okay, fine. So now we need activation function. I showed you that where do we use this activation function? We use activation function here. We use activation function here. Okay. So if we have multiple hidden layers, we use like uh, uh, many activation functions after, like for each layer you need activation function including output layer. And here you can see that like how to choose activation function for hidden layer. So you can determine like based on network type. Network means neural network type. Okay, so if it is multi-layer perceptron, ReLU activation function is used. If it is convolutional neural network, ReLU activation function is used. If it is recurrent neural network, sigmoid and 10H activation functions are more suitable. So depending on the type of neural network, you can choose activation function for your hidden layer. And if there are n hidden layers, n activation functions are required. How can you choose an output layer activation function? It depends on the type of problem. See the change. Okay, how to choose the activation function for hidden layer and output layer. Only difference is here. Here we see for hidden layer, activation function is chosen based on the type of network, based on the type of the neural network. While for output layer, activation function is determined based on the type of problem. So if it is a classification problem, then again, like you have to check whether it is binary classification problem, multi-class classification problem, or multi-label classification problem. If it is binary classification, you can use sigmoid activation function. If it is multi-class classification, softmax activation function is used. If it is multi-label classification function, then sigmoid activation function is used. But if the problem is a regression problem, because those again like who have learned machine learning, they must be familiar with this classification. In supervised learning, is usually used for classification and regression problems. We have discussed three types of learnings, right? We have learned three types of learnings: supervised, unsupervised, and reinforcement learning. Now, supervised learning, it is usually used to solve classification and regression problems. So if it is a regression problem, then linear activation function is preferred. Okay. So this is how you can choose activation function for hidden layer and output layers. Okay. So here, as we are discussing this classification and I recall that I wanted to discuss differences between three types of learning: supervised learning, unsupervised learning, and reinforcement learning. So before we move to loss functions, let us discuss the differences between these three learnings, and then we will discuss the loss functions and optimizers. Okay, because it is yet pending. I wanted to discuss, I missed it when I discussed these three types of learning. Differences between, yeah, it is here. Differences between supervised learning, unsupervised learning, and reinforcement learning. Those who have not learned machine learning, they can be with me. This is very useful to understand the three kinds of learning supported by machine learning. Okay. So these are the, on left side, you can see that in blue color column, the different parameters are given with respect to which all these learning techniques differ from each other. So these are the parameters like data set, learning type, how it learns, objective, training, analysis of data, type of problem, algorithms, approach, accuracy, and applications. Okay. So if we talk about the data set, if we use supervised learning, then you need labeled data set. If label data set is available, then you can train machine with this label data set. Like it is kind of teacher is teaching to student. Teacher is teaching or parents are teaching to children. So label data set is available. Input and output variables are given in pairs, like input and associated output is also given. Okay, suppose cat picture is given, then along with that picture, its label cat is also given. Dog picture is there, along with that picture, dog, it is also given. Such labels are given. That is called label data set. So supervised learning is suitable when you have labeled data set. Unsupervised learning is used when you have unlabeled data set. Pictures are given, but no names are given. No tags are given. No labels are given to those pictures. Machine has learned on its own from pictures. How it can classify, or how it can categorize those images into different clusters or different. Okay, so that is unsupervised learning when unlabeled data set is that. Only input data is given, output data is not given. Associated with input, output labels are not given. That is unsupervised learning. Reinforcement learning, no predefined data. No labeled data, no unlabeled data, no predefined data, does not require data, and it learns by interacting with environment. And I gave you example of self-driving car. I gave you example of AlphaGo game, right? So they are reinforcement learning based applications, self-driving car. No predefined data, right? It doesn't require data. It learns by interacting with environment. Okay, so this is with respect to data set, how these three types of learning differ from each other. The next is learning. In supervised learning, the learning is instructional based and needs supervision. Learning is instructional based and it needs supervision. Moreover, machine learns by following examples from the label data set. Machine learns from the examples in data set because labels are provided with input data. Machine learns that, okay, this is called cat, this is called dog, this is called horse. Labels are given. So it learns in repeated iterations, in repeated epochs. Okay. In unsupervised learning, machine learns by reasoning and does not need supervision because like no labels are there. So no supervision. It learns by reasoning. It has to figure out that what is there in image, what is there, and it learns by reasoning. It identifies hidden patterns to extract insights from the unlabeled data set. So many things you to learn on your own in your life, right? Some things are taught to you by your siblings, by your parents, by your teacher, but everything is not taught to you. Many things you learn on your, as you grow, you analyze, observe, and you learn on your own too, right? So this is kind of like unsupervised learning, when you learn on your own through observation and analysis. Okay, reinforcement learning. Machine learns by experience as it explores and exploits different actions to maximize long-term rewards, right? If you remember, we discussed that if it takes right decision, rewards are given. If it takes wrong decision, then penalty is charged. So this is how it learns by experience, right? When you do something wrong, you may be punished by your teacher or your parents, and you learn in next time you should not repeat this, because otherwise you will get punishment. Similarly, machine also learns from rewards and penalty. If it gets rewards, it it learns that it has taken right decision, and if it like penalty is charged, machine will it has taken wrong step, wrong decision. Okay, the next parameter by which they differ from each other is objective. This supervised learning is used when we want machine to learn only one type of task. When we want machine to learn only one type of task, then supervised learning is used. It machine predict outcomes for new data belonging to the same domain. Okay, so that is for what we use machine learning. Unsupervised learning is used to gain insights from the unlabeled data that can predict if the new data is a part of the cluster or an anomaly. So here, like new data, it is also possible that, okay, let me tell you, see what's the difference. Suppose you are feeding machine labeled data, and let us assume that that labeled data includes images of cat and dog only. Okay, so it has learned this type of task. It has learned, machine learns from this data to differentiate between cat and dog. Now, suppose after training that machine, you are feeding image of horse to this machine. You are feeding image of horse to this machine. Machine cannot rightly identify the label for this image because it is not trained for that. Okay, but in case of unsupervised learning, if after training, if you feed any such very if you feed like very different data, then what it will do, it will create a new class, it will create a new category for that, right? Because it get insights from unlabeled data that can predict if new data is a part of cluster or not. If not a part of cluster, already existing cluster, it creates new cluster. When it learns, what it does, it creates new cluster. While in case of supervised learning, cat and dog, two classes are fixed, cat and dog. While in this case, when it learns, it keep on creating new classes when it identifies new type of data, right? So similar data are clubbed and they are put into the same class. Objective of reinforcement learning is learn sequence of actions by exploration and exploitation in an uncertain environment to maximize future rewards. And it can handle an entirely new scenario it has never encountered. And that's why we use reinforcement learning for examples for real-time applications like self-driving car. It can handle an entirely new scenario it has never encountered, right? So that's why reinforcement learning is very powerful today for many complex real-time applications. Okay, the next parameter is training. In supervised learning, external supervision is required. In unsupervised learning, no supervision is required. In reinforcement learning, no supervision is required. Okay. Okay, the next parameter is analysis of data. Supervised learning use offline analysis, while unsupervised learning online, and it uses real-time analysis, and even reinforcement learning online and it uses real-time analysis. Type of problems which can be handled by supervised learning are classification problems and regression if you thing, right? Then you can use this supervised learning. You can use this supervised learning, right? Unsupervised learning, it is used for clustering and association. It is used for anomaly detection. Unsupervised learning. And this reinforcement learning, it is used for the exclusion or ignoration. Okay. Algorithms, okay. I am sure you are familiar with the like real-time classification problem, regression, clustering, and all. Okay, the next parameter is algorithms. Which kind of algorithms are popular or available for supervised, unsupervised, and reinforcement learning? For supervised learning, linear regression algorithm, logistic regression, support vector machine, multi-class classification, decision tree, Bayesian logic, and then naive bias. All these are popular algorithms, traditional machine learning, supervised machine learning algorithms. Okay, unsupervised learning like clustering algorithms, K nearest neighbor, which is KNN, or priori algorithm. These are the examples of unsupervised learning algorithms. And reinforcement learning, you might not be familiar with this because usually supervised and unsupervised, these are the very popular, they are widely used and they are very popular. Okay, for reinforcement learning, Q learning, then SARSA, like either value-based, policy-based, or model-based, right? This kind of learning algorithms are available. These are algorithms. Like if you want to learn about them, you need to refer to literature and you need to study them in depth. Okay. Approach which we use for supervised learning is maps the label input to the known output. Okay, that is the approach in the supervised learning that maps the label input to the known output. In unsupervised learning, approaches understands patterns and discovers the output. Like it itself has to, machine itself has to learn the patterns. It has to find the trends. It has to find the patterns. Okay. And then it learns and it discovers that output. If like it creates initially, like there are no classes, but as it learns, it creates the clusters. It creates the groups, categories. Okay. Reinforcement learning follows and that's why, like, in supervised learning, when it is classification, we have fixed number of classes that input has to be, input can be, input can fall into one of these categories. Fixed number of classes are there. While in unsupervised learning, when it learns, okay, we don't know how many clusters it will create. It may create 2, it may create 3. It depends that how data points differ from each other. The samples in data set, they differ from each other. So maybe 2 classes, like you can say 2 clusters, 3 clusters, 4 clusters, and so on. Reinforcement learning follows the trial and error method and that's why, like, if it makes mistake, penalty is charged. If it takes right decision, rewards are given. So it is completely based on trial and error method. Okay, accuracy of supervised learning. Supervised learning model, they produces an accurate result because classes are fixed, model trained input and output, like it's a supervised learning, right? The right things are taught. So the chances of making error are very less. And so this learning algorithms are considered more accurate. Unsupervised learning model may give less accurate result as compared to supervised learning because model has to learn on its own, no supervision. So model may learn right, model may run wrong, right? As like you can compare this with a real-time day-to-day life scenes. Like when you learn on your own, you may make mistakes. But when it is supervised learning, the chances of mistakes are less. Okay. Applications, supervised learning, classification algorithms, and it is used to detect fraud, spam, like whether transaction, financial transactions transaction or it is non-fraud. It is used to detect whether email is spam email or non-spam. It is also used to classify images, objects, etc. And it is also used for prediction like weather prediction, sell prediction, house price prediction, stock market prediction. We use this supervised learning. Okay. Unsupervised learning, the applications of unsupervised learning are customer segmentation. Suppose financial organization has several customers and want to segment them into, suppose that organization, financial organization, maybe bank or some other financial organization, they want to categorize customers into different categories, into different segments. Okay, so there we use unsupervised learning. Market basket analysis, very popular term. uh, Fraud detection, network security analysis, we can use this unsupervised learning. Reinforcement learning, it is used in robotics. See, it is usually used in very complex applications, reinforcement learning, where we don't have data because no, if no data, no predefined data is available, we have to use reinforcement learning. If we don't have predefined data, then we can't use supervised and unsupervised learning, and only a type of learning which we can use is reinforcement learning. So that's why like, this reinforcement learning is very popular for robotics, developing business strategies, self-driving cars, gaming. In healthcare also we use like specific in healthcare we use this reinforcement learning, right? So these are the different applications of different types of learnings. Okay, so this I missed when I discussed about the three types of learning, like this reinforcement learning and unsupervised learning and supervised learning. Fine. Okay, now before we move forward, I would like to take your questions for this types of learning and activation functions. Any question from your side? You can also type your question in chat box. Students, feel free to ask any question, right? Because through questions only you can learn, new, like new things. You can learn the, sometimes I forget to discuss a very small point or minor point, which is also important related to topic. But if you ask questions, I remember to discuss those points also. So keep asking questions. Okay, it seems no questions. Okay, fine. Then we can move forward towards loss function. So let me first, now before we move to the, before we discuss the different types of loss functions available, let me tell you what exactly the loss function is. Okay. Okay, now loss function for binary classification problem, for multi-class classification problem, we have different loss functions. For binary classification, we have like this activation function based on type of problem, we can choose loss function. So if we briefly define that what exactly the loss function is, if you remember, we discussed this about when we discussed about the basics of neural network, that once the output is predicted, the difference between actual value and the predicted value is computed. So what is the loss value? Loss function is a mathematical function This is also a function, mathematical function, that quantifies the difference between predicted and actual value, which we discussed earlier too. So in any machine learning model, this is also not concept related to only neural network. This is related to any machine learning model. It is a difference between predicted value and actual value. It measures model's performance. If difference is large, then model is not performing good. If difference is small, model is performing good. So it measures the model's performance and guides the optimization process by providing feedback on how well model fits the data. So, uh, so this is called loss function. And loss function and cost function. These words are used interchangeably in deep learning. In machine learning and deep learning, this loss function and cost function, these words are used interchangeably. They both refer to the same concept of a function that calculates the error or discrepancy between predicted and actual values. And this cost or loss function is minimized during model's training process to improve accuracy. So why we train model through different epochs? The aim is to minimize this loss function. Aim is to minimize this cost function. So that because when it is minimized, accuracy of model improves. Accuracy improves. So that's why the objective is to minimize this loss function or cost function. Now, different loss functions are there. Like we can also L1 loss and so many loss functions are there. Okay, what's the time? 5 minutes are left. Okay, 3 to 5 minutes are left. So I think I'll start exact discussion on loss function like MAE loss function and many loss functions are there. So we'll discuss those loss functions in next class. And meanwhile, if you have any question, you can ask. Like we have 5 minutes left. So let us discuss. Let me clear your queries if you have any. No question today? What is the accuracy of reinforcement learning? Yeah, it learns based on trial and error. So we cannot make any general statement about the accuracy of reinforcement learning. And that's why that cell is empty in my slide. Because it has been observed that supervised learning, we have label data. And when it is supervised learning, learning is always comparatively good from through supervision. And that's why the model accuracy is comparatively higher. When it is unsupervised, it is by on its own, so it may learn right or wrong. Okay. And similarly, and that's why compared to between the supervised and unsupervised, supervised gives higher accuracy compared to unsupervised. But now when we include reinforcement learning and compare the accuracy of reinforcement learning with supervised and unsupervised, like we cannot make any general statement, because it again depends that how many wrong decisions reinforcement learning model or algorithm has made. If it has made many wrong decisions, then more penalty is charged and learning is not good, it may give less accuracy. But if it has made many good attempts and many right decisions have been taken, then it will be like rewards will be given, learning is good, and in that case it may produce good results with good accuracy. So that's why like that that part was empty in my slide. Okay. Then next question is, what is the regression and elastic net? Okay, regression, lasso and ridge regression, they are regularizations, right? And if you remember in last class or last to last class, we discussed about the overfitting problem. And if you remember, we also discussed that there are several ways to overcome the overfitting problem. And among the several ways, the one of the ways is you can use regularization. You can use this regularization, lasso regularization and reach regularization to overcome overfitting problem. Okay. Okay, the next question is, technical issues and was not able to join the session on time today. Is there a chance you could provide a brief overview of the material covered? I think these classes are recorded and they may be shared with you. The recording may be shared with you. Moreover, later I will also share notes and I will also share PPT. So I think when you like, you can synchronize PPT with notes and you will understand. Fine. And you can also like, if recording is shared, uh, you will be able to understand topics discussed in today's class.